Assalamu alaikum. Hello viewers. Today I've come to discuss with you some problems from the application of integration. In my last lecture I tried to give you some example from the integration, different types of integration, and in this lecture I will discuss with you more practical problems. Here the first problem is we have to sketch the graph y is equal to 1 plus sine 2x, where x is 0 to pi by 2. The area enclosed by the curve, the axis, and the line x is equal to pi by 2 is rotated through 4 right angles about the x-axis. So we have to calculate the volume of the solid of revolution. Here given y is equal to 1 plus sine 2x x, where x is 0 to pi by 2. So our required volume is V is equal to V1 plus V2, and in case of the solid revolution, when we have to find the volume of the solid of revolution, then we will and use this formula. Since it is along x-axis, so here it will be dx, and for now we substitute the value of y, which is 1 plus sine 2x whole square. Now we apply the a plus b square b whole square formula, 1 plus 2ab plus b a square plus 2ab plus b square. Here we have to transform it to sine square 2x, so that we can apply 1 minus cos 4x. Then we can easily integrate AB terms. Now after integration we get this, where we have to apply the limit, and after applying the limit we get this expression. And again our second volume is from this limit we have to apply the integration here, and now we get this, we apply the limit. After applying the limit we get the required volume, and after adding these two volumes we get our required volume, total volume, right? Now we are going for our second problem. uh, though it is problem 3 here I wrote, but I will discuss this as second problem. Here the area enclosed by the curves x equal to y square and the line x y equal to x minus 2, it is rotated through 360 degree about the y axis. So we have to calculate the volume generated. So I'm trying to discuss with you similar type problems. So let's say here our first curve is x equal to y square, and second y is equal to x minus 2. We transform it to x equal to y plus 2. Then we substitute the value of x from here to this equation, where we get y plus 2 is equal to y square, then y square minus y minus 2 is equal to 0. From this, after factorization, we get the value of y is 2 and minus 1. Then the required volume, where we required volume, generated volume, from this formula we get here x1 is y plus 2 and x2 is y square. Okay, and after this is a formula, we know that if we are given two curves, then it will be like this. So we use this formula here, right? And then after applying our integration and limit, we get our required result. So these two are similar problems for which came from the revolution of any structure. Now we are going for the kinetics problems. In kinetics, how we apply the integration. We know in kinetics how we calculate velocity. Velocity is distance by time, and acceleration and dv by dt. right? Dv by dt first, then we from dv by dt we get d square s by dt square. So if we apply integration here, we get the distance, right? Like this formula, right? And similarly, if we apply integration here, we will get the velocity. So this is the application of integration in kinetics, huh? So now come to the problem here. A particle moves in a straight line so that t seconds after passing a fixed point O, its acceleration is a centimeter per second square is given by a is equal to 40 minus 16. It passes O with a velocity of 30 centimeter per second. We have to find an expression for the velocity of particle in terms of t, and we have to show that it comes to instantaneous rest when t is equal to 3. And also we have to find the distance of the particle from 0 when t is equal to 3. Here we are given a is equal to 40 minus 16, 40 minus 16, and when we integrate both sides we get v is equal to 2t square minus 16t plus c. When t is equal to 0, v is equal to 13, so c will be 30. T is equal to 0, we get if we apply t is equal to 0 and v is equal to 30, we get c is 30. So the velocity will be 2t square minus 16t plus 30, and we know it comes to instantaneous rest when v is equal to, then v is equal to 0. When it is in instantaneous rest, then v must be 0, and if we apply v is equal to 0, we get the value of t will be 5 or 3. So we can say that at t is equal to 3 seconds the particle comes to rest, instantaneous rest. Again from this expression we get b is equal to 2t square minus 16t plus 30. If we apply integration both sides, we get the distance, which is s equal to 2t cube minus 2t cube by 3 minus 8t square plus 30t plus c. If apply t is equal to 0, s equal to 0, and c will be also 0, so the value of distance, or that means distance will be 2t cube by 3 minus 8t square plus 30t, right? And at t is equal to 3 second, when t is 3 second, then s will be 2 by 3 cube minus 8 3 square plus 30 times 3, that is 36 meter, right? Now we are going to see another problem from kinetics. Here, this is another problem from kinetics. Here, a particle traveling in a straight line passes a fixed point O with a velocity of 8 meter per second and acceleration of minus 2 meter per second is 2 meter by second square, and it moves in such a manner that it t seconds after passing O, its acceleration is f meter per second square is given by this. And during the first second after passing O, it moves through 9 meter, and we have to calculate the value of a and b. So notice here f is a plus bt, right? We have given expression for acceleration. We we can convert this like from this equation. We know f is equal to dv by dt, and if we change it, we can get db is equal to f dt, and if we apply integration both sides, we will get a velocity, right? So here we apply the integration on both sides of acceleration expression equation, and we get the velocity, and here the value of f will be a plus bt, and if we integrate, then we get v is equal to at plus bt square by 2 plus c. And but we know when t is equal to 0, a v is 8, right? Here at the first of the question, in the beginning of the question, we said that a particle traveling in a straight line passes the fixed point. When it passes the fixed point, the velocity is 8 meter per second and acceleration is minus 2 meter per second square. That means when this particle passes this point, initial velocity is 8 meter per second and acceleration is this. So when we apply t is equal to 0, v is equal to 8, we get c is equal to 8. Similarly, when t is equal to 0, f will be minus 2. This value, if we apply this value on this expression, f equal to a plus b2, we get the value of a is minus 2, right? Now we are going for the finding the value of b. Now putting the value of a and c, we get from 1 is b is equal to minus 2t plus bt square by 2 plus 8. Here b is ds by dt, and from that we get a d is equal to this expression, and if we integrate from both sides we get this a is equal to minus 2 times t square by 2 plus b by 2 times t cube by 3 plus 8t plus c. And if we apply t is equal to 0, s equal to 0, and c equal to 0, then we get s equal to minus t square plus t cube times b by c plus 8t, right? And when we apply t is equal to 1 and s equal to 9, then we got 9 equal to minus 1 plus b by 6 plus 8. So the value of b will be 12, right? And the value of a is minus 2. So these are problems for today I tried to discuss with you. Please, if you have any question about these problems, or if you are traveling with any topics or any problems from your books, let me know, and ask me in the YouTube or comment box or through messenger, Instagram. I'm available now on my Facebook, Instagram, and even TikTok. So try to follow me and subscribe my channel in YouTube. Hope you all the best. Thank you everyone.